In section 4, we are going to take what we've been doing, and instead of having equations with an equal sign, we're going to have inequalities with, an inequality symbol. The key difference, the only thing that changes here, my friends, is if you multiply or divide both sides of an inequality by a negative number, we must flip the inequality symbol. That is the only thing that's different here versus what we've been doing. So this first guy is a two-step inequality. We will add 3 to both sides so that 2x is greater than 8. And we'll divide both sides by 2 so that x is greater than 4. That is solving. Graphing. It's been a while since we've done this. We throw down a number line. On that number line, we put 0 and the number we got for our solution, which is 4. Above the 4, we put a circle. If the inequality had a bar on it, was greater than or equal to, we would fill that circle in. This one doesn't, so we don't. X is greater than 4. Greater than is this away. It's not the best looking graph, but it'll do. Okay. The next problem is fine, except for it's totally backwards. With inequalities, it is pretty important when it comes time to graph that x be on the left side. I'm going to solve this normally, and then we're going to rotate the entire solution. Okay, so if this were just a normal thing, we would subtract 2 from both sides to get negative 12 is less than 3x. And we would divide both sides by 3 to get negative 4 is less than x. You note, I didn't flip the inequality sign because I divided by a positive 3. I don't like this. I'm going to reverse the entire thing. X is greater than negative 4. Make sense? I don't know why I'm asking. You can't tell me if it doesn't. I hope that makes sense. I'm doing that to make graphing it a whole lot easier. So I'm going to throw down my number line. I'm going to throw down negative 4 and 0. Please put negative numbers on the left side of 0. We have an open circle because this is a strict inequality. It doesn't have an or equal to on it. And x is greater than that, so we throw our arrow coming out of that to the right. Okay. It's combining what we're doing now with some stuff we haven't done since, maybe October. Possibly November, but my money's on October. It's been a while since we graphed a number line like this. All right, so let's slide this. And grab my pen back. Again, two-stepper. Obviously, you can see the negative on the 2 with the x. That's so we remember how to deal with this. We are going to subtract 4 from both sides to start our life. So negative 2x is less than or equal to negative 1. No big deal yet. Now I'm going to divide by negative 2. So x. I divided by a negative, so I have to flip the inequality. It's now greater than or equal to. Negative divided by a negative is positive, and 1/2 we leave as 1/2. To graph that, we throw down a number line. We put 0 and a half on the number line. Remember, I'm not sitting, I'm not measuring, I'm not expecting perfection. I want 0, I want the number, and I want the right symbols above the number. So greater than or equal to 1/2 means I will fill in my circle as best I can above 1/2. And greater than goes that way. Lexus Marie, calm down. Lexus Marie is my dog. Yes, she has a middle name. Yes, just like you children, she gets called by her first and middle names when she's being ridiculous. And now she's taking a very large and loud drink of water. I'm sure you can hear. So our next example, we have some like terms we have to combine over here first. We can't just dive into this. We have a 3x and a negative 4x together on the left side. So we combine those into negative x minus 2 is greater than 5. This is now a two-stepper. We will add 2 to both sides So we get negative x is greater than 7. I can't have negative x, so I'm going to divide both sides by negative 1. Because I divided by negative, x is now less than, remember that flips when you divide by a negative, negative 7. So we throw down our number line. We put negative 7, maybe, if it lets me write, without constantly vanishing. Okay, you know what, word? Why you gotta be like that? Why? Why do you have to be like that? Okay, so let's erase that. I'm gonna put this way down here for a second, just because... Oh, come on now. Okay, can I put it up here? Apparently up here is fine. So we'll slap down negative 7, we'll slap down 0. We'll put an empty circle above the negative 7. And less than goes to the left. Okay, so now we can erase all this. Forgive me when I'm done erasing this. There's going to be an awkward silence for a moment because my dog is insisting she be let outside. And I am about 5 feet from the back door. So give me one moment. Okay, I'm back. Yes, I could in theory go and edit the video so that's not there, but let's be honest, I'm not a video editor. I'm a math teacher. So enjoy those few seconds of silence and look up a picture of a dog. Our next guy, fractions. Oh no, but we know how to deal with fractions. We multiply. Now why is everything disappearing? Okay, I think we solved that. Okay, now the technical hiccup is out of the way. Multiply everything by the least common denominator. The least common denominator is 6. 6 divided by 3 is 2. 2 times 2x is 4x. 6 divided by 2 is 3. 3 times 1 is 3. And that stays less than or equal to. 6 divided by 6 is 1. 1 times 5 is 5. I invite you to pause the video and finish this. We will subtract 2 from both sides so that 4x... How about if we subtract 3 from both sides? That probably makes a little more sense, doesn't it? Let's subtract 3 from both sides so that 4x is less than or equal to 2. And divide both sides by 4 so that x is less than or equal to 1/2. 2/4 simplified as 1/2. Throw down our magical mystery number line, give it a 0, give it a half, less than or equal to. So this circle gets filled in, and less than heads off to the left. Okay. And last, we have an example where there are variables on both sides, but we know how to tackle this. I'm still going to follow my rules where I move the smaller version of the variable first. So I'm going to subtract 2x from each side to get 3 is greater than 3x minus 6. This is now a two-step problem. So we will add 6 to both sides to get 9 is greater than 3x. Divide both sides by 3 to get 3 is greater than x, which I'm immediately going to spin completely around to x is less than 3. Reversing the whole thing because it's a lot easier to graph when your variable sits on the left side of the statement. So I throw down my number line with 0 and 3. I put my empty circle above 3 because there's no or equal to on this inequality, and throw my arrow off to the left.